Hello! Today in this tutorial, this is the second tutorial on compositing and LPE. And in the first tutorial, I have showed you what you can do with LPEs. And in this tutorial, I will show you how you can integrate a CG object into a shot, into a real photo basically, or into a recorded shot, how you can implement those objects and how you can preview the integration before you go to compositing. And there are really a lot of ways to do that. I will show you today the most easiest one. I will also show you or give you a very brief introduction into LPEs. What are LPEs essentially, and how I use those LPEs in my project. So in the end, the first thing that we need to talk about is what are LPEs. And this is, it's really hard to describe. So first of all, it's an expression language. So it's like every language that you learn, you have a syntax, you have different ways to describe a thing. But moreover, LPEs are a way to tell Renderman how to collect light samples and bring it to a AOV or to a layer, so you can use it later in your compositing project. And LPE is the most powerful tool in Renderman, in my personal opinion, because there are a million ways of collecting those light samples. And often, also when you do VFX shots, you need some specific layers for resolving a situation that you have in your shot. Maybe you need to correct the background, or you need a specific light bounce. And LPE can deliver that. So for that, Pixar's Renderman documentation is really good at this. They created a site, basically a site only for LPEs. And here you have a very detailed explanation what LPEs are. So when you want to use Renderman on a very professional level, also in regard to VFX, you have to learn that stuff. It's really hard, it's not easy, and it's not learned in one day. So I struggled myself in the first place because like I've said, I come from the background of having everything with a checkbox button. And this is not always a nice way to do that. So Renderman has the expression. Also Arnold has some sort of LPEs. This is a very common thing. And I also know that Karma will have those LPE expressions to output AOVs in the future. So there are two sites. I will link those sites into the description box of this tutorial. There's also a second site, more specific on example. Here you have additional information, more in general. What are lobes and so on, and how you can use them. And you really learn the essence of this language. So, but for us, we don't need to dive that deep into that matter. I will show you what you need to do for those basic holdout workflow today, and what you can do also with the presets that you have in Houdini. So when this is the other one. So when we create a Renderman ROP right here, what was the original one? We create. So basically we also have some presets right here under customs, and here we can choose the most common LPE functions. And here you have them, and we can use them, we can reuse them we can use parts of them, and so on. I will show you how you can do that step by step in a hopefully very simple way. I know this can really struggle, but I hope I can get it right. So first of all, we want to create an object into the background, and for that I went out and I took a photo on a wall that really a lot of people use in summer to sit there, to meet with friends, and to have nice conversations. This is a very common place in Dresden on the River Elbe, and the beautiful skyline of Dresden, if you will. And for that I have recorded not only the background footage that we see right here, where we have a very hard defocus and a very thin area of sharpness. Into that sharpness we will integrate those objects. I also have recorded a metashape scan. So I took 8 photos. In fact, only 3 were used in that example. And I've scanned the underlying ground. This is a really nice method to match up the camera, because on a wall you have some dirt and you have the rock itself, or the sandstone in my case, has different features. So where is the button? Here's the button. So we have a lot of different features on that wall, and we can use this to match up the camera when we don't use any tracking software. So this is a really good trick for doing this on a still photo. Also when you don't have enough features like edges and so on, it will really help you to understand where you have to place your camera. So that's why I recorded that mesh, and it is also really dense. So as you see right here, it's really dense. It's not 100% accurate, but we don't need that 100%. So I brought that to Houdini, and here I also done some poly reducing, so we don't need those 4 million polygons. We only need a portion of that. This was looking like this, and then I activated, or I used the UV quick shade function to visualize the texture. And what you see here, okay, we can deactivate the sphere for a second. So what you see here, we have some features like this one and this dark area here, and I really tried to match those up a bit. Like I said, it don't have to be 100% accurate. It should stick as close as possible. Then I maybe can move the camera a bit. Oh, wrong mode. How to update, quite important. And then we basically can move it right here. Check it again. I think that's matching a lot better. Maybe not in that area, but who cares? So the next thing that I did is I stretched I cut it the surface on top, on the most top edge right here with a clip, and then I mirrored it back and I edited it a bit to give us more space in the shot itself. So we have some features in the mesh, which is good for the shadow later. And the next thing that I have done is I have added the spare parameters. You can do this by clicking, I will show you that. We create a new sphere because we need that sphere. So we will place a sphere right here. Maybe we can move it more towards us. So maybe right here. So it's sticking. It's not sticking into the surface that much. And then I select the object and go to the Renderman tab and hit Add Spare Parameters. And here you have all the spare parameters that we want to use. And this is exactly what I did on the geo object. We can also call this object ground for now. And yeah, maybe we should bake it. So now we have baked it, so Houdini don't need to recalculate it every time. And we can call this stage 2 or stage 1B. So we don't the second one is my test, so I'm able to correct me when I did something wrong, or if in the case something isn't working. So we call it 1B. So we have it here. And you also get all those files in the tutorial. I will provide all those files, all the footage, the HDR, and all the objects that we put into that shot. I will provide the entire project for you, also with the fusion examples and so on. So you can go into that tutorial and basically jump between each chapter. And yeah, so we gave the name ground. And we need to go to Renderman. So we select the object and then we go into those parameters that we have added. Under attributes and under trace attributes, I activated the Holdout checkbox. This is what we need in the next step, because we don't want to see this 3D model. We want to integrate the sphere into the background. So we only need this object as a placeholder or as a surface which is collecting the shadows, maybe the reflections, speculas, and so on. And yeah, so this is our holdout object. So we have activated this. The next thing that we need to do is we need to add so-called image filters. We do this on the shop level in the RisNet 1, and usually we have the path tracer right in here. And the next thing that we need to do is we need to find a combiner, and we need to use the display filter combiner. Here we add 2 new entries. The first entry that we need to do or need to have is our background image, because we want the shadow on our background image. So what we want to use is the Pixar image display filter. So you get it right here. Where is it? Image display filter. Oh, wrong menu. So here. The next thing that we need to do is we define our shadow LPE AUV. And here we can choose a name. We can use any name that we want, but for keep it clear so that every artist can understand that, we call this shadow. Shadow. So this will be our holdout shadow path later. And then we also need to add our background footage. So we have it here. It's already converted to text. It's worth to mention that every time when you want to integrate something into camera footage, so you have a sequence that you have recorded with your camera, you need to pre-convert the entire sequence to a texture sequence or to a text file. That also is important when you deal with maybe you have a screen and a screen animation that you maybe built in Nuke or in Fusion, and you want to display this texture animation on a screen in your shot, on a virtual screen. you need to convert the entire sequence to text files and then read the text sequence. Renderman isn't able to read a EXR sequence, image sequence, so use the text file natively for all texturing operations. So this is what we have, and this is everything that we need in the display filter. Then we will put it onto the low one with drag and drop right here. This is the one, this is our background basically. So I found out that this is like a Photoshop layer system. So the last entry is basically the entry which is on the bottom of your layer stack. So the next thing that we need to add is a shadow display filter, and we get it right here. And here we need to add 2 more layers later, but we define the namings now. So in the shadow AUV, we use the same as we used in the display. So we can copy paste this, or we can type the same right here. We call it shadow. And here we can go the easy way and write unoccluded. And here we need occluded. So those are the namings for the other 2 LPE functions that we use. And then we go back to our, we missed something because we need to add this to the combiner first. So, and then we go back to our RIS node. And here we go to the Advanced tab, scroll down to Filters, and here we choose the Display filter. And here we go to the Shop Network and choose the Combiner. Relative path. So, we use the Combiner right here. So both functions will be used in the combiner. So then we will define our output LPEs. And for that we do 3 entries. The first one is called shadow. The second one is occluded. And the third one is unoccluded. And for that, we need those LPE functions, and all LPE functions are starting with LPE : So we can do that right here. And for the unoccluded, we need to tell Renderman that this is unoccluded path. So we can copy paste this right here and do a semicolon. And on the occluded, we do the same. Let me check that I don't make a mistake in the other example. Okay, I did a mistake. We only need holdouts right here and holdouts also here. So let us copy paste this. I will describe what I did or what this means. So we copy paste those functions. I will also provide you the file so that you can save this as a preset for yourself. Oh, that's not what we want. So we have it right here. So first of all, every LPE function starts with the LPE convention and then colon and then C. C is an event. So every of those letters are events, and when you basically want to understand it, we name it a layer like here. So I want to show you what that means. So first of all, the camera is what we use. The camera is the thing that basically will collect the sample rays. So this is where we want to have those, we want to have it on a layer. So we need to read those with the camera. So that's why the C, the short form is C. Then we basically can divide that into three different sections. The first section is what we want to collect, and then how many bounces we want to collect. And the last thing is basically what light rays we want to collect. This is basically the scheme of this entire thing. So when we move over here, what we see right here is reflection diffuse. So this is also an angle brackets, and angle brackets are only describing a single event. So we only want to collect basically the diffuse reflections, the reflections that hit at one point the camera. We don't use any specific bounds between those two events because we only want to have one single event. So what we can do is basically we can use an asterisk function, which basically would result in the situation that Renderman will collect all light rays, all bounces and all indirect light rays. But for a shadow pass, we don't need that. So that's why we have not this in between both boxes. So the last thing is, The last thing is basically what lights we want to use for recording. So this is basically the L, and the dot means that we don't care about if it's a emissive light and so on. So when you want to have more detailed explanation what this is, you can always go into the documentary, but it's, like I've said, it's really a hard topic. So the next thing that we need to do is we go back to our scene. We don't need the old one. Close this. Now we need to add some light to this. So we will create a light dome. And we need the Pixar dome light for this. And here we will load our HDR, which I already have converted to text files. And we also need to add some materials to this. We will do this very quick. So we will create two materials, or we only need to create one material. The other material for the sphere comes from the library, from the Renderman material library that comes with Renderman. So we want to have chrome material, import, and then we go back, and then we drag and drop this to the sphere object. And now we have it on the sphere in the material parameter line, and the other material will be very basic. So we want to have a normal surface material. Link it right here. We need a manifold 2D for the texture. I always use them, and I hope everyone will use them too. Sometimes it's really important to have this. And then we also need a texture. We link that result into the manifold, and this pink one into the diffuse. And here we load our texture that we have captured with our 3D scan, which was already converted to ACES 2. So, and we call this material ground, and we will drag and drop it right here. And maybe we will make it, this is better later on in Fusion or Nuke when we use Cryptomat. So we check, it has detected the material, then we will save it and we do a test render again. And it will look bad. And this is because of two things. The first thing is our light, or when I created the HDR, the light direction or the axis of the light sphere is basically inverted. So we will do this that way. We also will maybe rotate it a bit more like this. Maybe so. And for checking what we did, I will deactivate my background image, and I will, let us look what we have. It's also, our background footage is inverted. This is in the display filter. I don't know why this happens, but this happens really often. So we type -1, and then we will have the correct direction. The other thing that we need, so maybe we can boost this a bit up. We deactivate the ground again, so it's much faster. Our sphere also don't has any normals, so we need this. So, and for testing, I will also reduce the chrome roughness, the reflection roughness, to a very tiny amount, to have a better sense of, how the reflections look. This is always the first step that I do when I work on a VFX shot. Put a chrome ball inside and change the lighting as long as it needed until this sphere looks, like it would really reflect the background. So, which is currently not the case. As you can see, the contrast is way higher than on the background footage. Also, the direction isn't correct. So the light is basically behind us on the sphere, but in the shot it's on our right side. And I will also activate the subdivision function on the sphere. So we have a very perfect sphere. And then we will turn the light itself until the reflections are fitting. So now we don't need that. We close this. So, and now we will rotate it, hopefully into the correct direction. So we will line up with this wall and also with the reflection. So this is lining up. This is perfect. So this is the correct direction. But now we have also a problem, because here we see the light brightness isn't matching with the background. So we will try to correct this. I will increase the exposure value a bit, and it's a bit of guessing always. We can try to match up also the coloring, and we also have to do that because right now the ground has a bit more green in it, and here we have more red. So I will adapt those values a bit until it fits. So maybe this fits much more. So we can use those color scanners to check if it's close by, and there's not much difference. So they are really close. Maybe not 100%, but maybe bit more. So here we have a bright one. Blue is 0.29, and here we have 2.2. So that means we have way too less blue. Maybe we make this a bit brighter. 28, 23, 29, yeah. I think that's matching. I hope this is matching much better. So we have this one here. 0.45, 0.40. Yeah, okay. I think that's okay. So maybe a bit red. We'll fix the red values a bit more. So like this. 0.81, 0.86. I think this is really close. So maybe we can make this. So this is the first important step. All the other corrections will be done in compositing later on, but this is the most important step to really get the light into the correct direction and also the shadow into the correct direction. So the next thing is we stop the render IPR and we will reactivate the ground, and I will save this as 1BC. So yeah, and then we need to check if our Riz node has all the layers, so we don't need that. We don't want to confuse the render engine. And we have our reflection diffuse event. We can make this shorter. Maybe we can type LO, which is the short version of that. So this should also work. And yeah, and then we will try it again with IPR and hopefully it will work. And oh yeah, it is working. But here comes the problem. Our ground material, our ground texture that we have isn't matching the background color. So the next step that we need to do is we need to match our texture to the footage. That's the next step. And for that we will create a color correct. And we will link it right here, right there. And here we will do the exact same thing. Maybe that's the wrong one. So we have a lot of blue inside of this ground. And it's also very bright. So yeah, we will make it a bit darker. A bit of the green should go away, maybe not that much. The nice thing on a grown ball is those colors are, yeah, the correct representation of all the reflections. So this is too much red. So it's not really there. So a bit more green. And now let us check again. Here we have some bright area. And it is matching a lot more, but not fully, I guess. So here we have everything right here is the reflection of the underlying geometry of our scan texture. And right here at this edge, this is everything from the HDR sphere. So don't wonder that those colors are matching and those colors are not matching at the moment. And yeah, maybe we should activate that. And maybe we can do that. Yeah, so maybe we do that right here. And this will look much, much better. So we have, oh, this is a way too bright. 0.4649. I mean, this is okay, I guess. Maybe too much saturation. So the second value is the saturation. Maybe too much. Maybe only a slight value. So yeah, so we go into the right direction. It really, really is starting to match up. So I think this is really close. Maybe a bit green out of the image. Yes, I guess this is looking nice. So now we have our shadows, we have our reflection, and then we will look into that. And what we see right now is, like I've said, this is our shadow path, and this is our occluded path, and this is our unoccluded path. So we can use the occluded and the unoccluded path in compositing to maybe color the shadow in compositing again, or recolor it with the unoccluded path, so we can mix those values. And what we also can do in this stage is we can add speculas into the ground material. But we don't have that much of specula because this is a very, very rough surface. But maybe we should add a little bit to this. So we choose the physical option, and we maybe crank up this value a little bit. Not too much. We don't want to destroy the result. And we will see the we will see this reflection also in this shadow path, because this is basically inserted path in the display function. So that's why you have the reflections also right in here, and you also get it also directly here. So yeah, the next thing that we can, maybe a bit less. Oh, this was too less. Maybe that's okay. So we have some bounces also here. So the next thing that we need to do is we want to create multiple passes for compositing. And for that I go back to my RIS node, and here I add a new entry, or maybe two. And the first one I call is only reflection unoccluded. So this is my layer name, so you see it right here. It's currently black, and here we can use those presets. And I want the direct specula. So we have the direct specula, which is only the HDR reflection basically. And but we don't want to have the reflection of the HDR. We want to have the reflection on the ground. So I will use the indirect one. So those are all the reflections And currently we only have this sphere. So when I would save this, when I will copy this object, the sphere, and move it maybe right here, you will see that we should, when we restart this, that we should get a second sphere right here. And also the second reflection. And also some indirect reflection bounces, or from on the ground from the object. So, and LPE gives us the ability to emit objects. So what we can do right now is we can say we want a separate path only for the left one and a separate path only for the right one. Maybe we want to do that in compositing. Maybe we want to change both materials or both reflection passes in compositing later on. So what we need to do for this is very easy. We click on one of those objects and go to attributes, to light attributes. And here is a line called identifier LPE group. And we will call this left sphere. And we will call this right sphere. Right sphere. So, and then we go to our Riz node and we will basically copy that exact same layer, this entire function. We don't need that color one, we only need LPE. And now we want to exclude an object, and for that we need the apostrophe sign and the LPE group name that we have defined. And I hope I do this right in the first place. So we had the apostrophe sign right here, and we will call it right underscore sphere. The sign again, and it has to be in the angle bracket. And then we will restart, and hopefully it has worked. And it has not worked properly, I guess. Yeah, let us finish the render. So, yes, it had worked. So, the reflection specular event, which is a single event right here, will only render the right sphere. But we can also do it in the opposite ways. We will use those squared brackets, and this should give us our result. And it's not working. Why is this not working? You see, it's really, really a hard topic. So, stop that. We do it the other way. So, copy paste. My mistake. So, yeah, in every language you have to be careful how you write down your stuff. So, the documentation is a page that you really have to be open and on a shortcut to have it open directly when you work on that. So we type right here the right sphere. The signs should work, and then we hit the IPR again and go to this one, and hopefully, oops, wrong button, oh my gosh. So, this is the right button. Yeah, we have the left one, but now we see a problem. We see that we also get the specular diffuse rays from the right sphere that we don't want to have in this path. So for that, I need to look into the documentation, and yeah. So I understand what the problem was. Because of the caret sign, I omitted this object, but not the other rays. So when we want to isolate only one object, we should use this way, like what we have in what we had in the first place. So the right sphere, and on that one we will, yeah, maybe we can do this again. So maybe upper stroke P, right sphere, that was the wrong one, this is the correct one, and here the left one, left sphere. So, and we will call this reflection sphere, left sphere. And here, copy paste this, right sphere. So, next try. So, left one, right one, it's working. And yeah, this is one way to isolate objects. And in the end, this will not really help, because as you can see, those LPEs don't have an alpha layer. So when I activate the alpha channel, you see it's completely white. Many users have asked me why this is the case, and the answer is quite simple. Every time when you create an alpha channel, the render operation in each render engine that is available will put into this anti-aliasing line, into this anti-aliasing calculation, 50% of the background and 50% of the foreground color into this edge, and will be blend between both. And this is the anti-aliasing effect, or the premultiplication effect that you get in compositing. So in order to get rid of this effect and to not have a double premultiplication, all the AOVs don't have an alpha channel. That's why also the shadow path doesn't have an alpha channel, as you can see. I hope this makes it clear why this is the case. In order to be able to separate and to have an alpha channel for both objects, we need to do some stuff. And what we need to do is we need to use Cryptomat. And for that, we also need to, that's the easiest way, we need to create two different materials, the right and the left one. And the right one is that, and the left one is that. And now I will create a Cryptomat filter, Cryptomat sample filter, and we will define output name and output path, which is important on Cryptomat, because those CryptoMat will be rendered always, even on IPR. So render, and here we will call it CryptoMat, or short CM, sphere test.exr, and we will use the material option. And this is all what we need to do. So we will render this image again with CryptoMat, and we let render it through, and then we will open Fusion in the meantime to check if our CryptoMat is working. I also, which is highly important, I forgot to mention that I want to activate the adapt all function. What that basically does is, when you have activated it, Renderman will sample each layer, each shadow layer, each AUV that you create with the same amount of samples that you have defined right here. When you don't have activated this, Renderman will only grab the already calculated samples from the beauty path and will copy those pixels into those layers. So this can result in very noisy shadow passes, for example. To avoid that, you should activate this. Of course, this can lead to oversampling in your compositing, because you have multiple rays on top of other rays. So yeah, you have to keep that in mind. The texture loading process comes from the HDD, which is really slow. So I think this looks really nice. We have those passes right here, and I will stop that, and then I will go to Fusion and I will check if the output was correct. And why I don't see an output yet? Yeah, here comes the next thing. In the Advanced tab, of course, you have to add the CryptoMat to the sample filter. Highly important. And now it should work. Stop, restart. So let us check this. It's created, it's not finished yet. So I will stop the IPR now, stop, and then we should have a final image, which will look like that. So here we have our two CryptoMat IDs. So, and we can check this with the CryptoMat plugin in your compositing app, and we will grab the left one, hit add, and we see we have picked the chrome left material, and when we output that mat, we will see that's the correct one. So we will copy paste this and we'll move it right here. Yeah, that's the correct one. Clear, add, to activate it. And here we have the right one. So the left one and the right one. So this is the method to isolate objects. So when we come back to our scene, we have now the ability to add all sorts of objects into the scene, and we can do we can maybe add some font right here, and we can play with that shot a bit. maybe something like that. Frame 1, don't need frame 1. Go right here and we'll type Renderman, for example. It's not the correct way to write Renderman. Something is odd right here. What's happening? Okay, it's not the correct font. It's really hard as a German to speak English for a tutorial. I hope this is not too distracting for everyone. So, and we will extrude this right here. So this is just playing around with that. And right here to do some more stuff with that. And here we can maybe add completely other material. We want to have some, let us add some, what can we add? Let us add some rubber material to this font. Let us render this again. So we have the font right here. Oh, there's sometimes happening that the camera is moving out. And as you can see, it really worked. But what not has worked yet is the defocus. So the next step will be to integrate the defocus into this render. So here's our shadow path, the occluded, unoccluded. This is our reflection path. We see a reflection of the font in the background, also right here. And we need to add some sort of defocusing now. And for that, we will stop the IPR first of all. Then we will go to our Riz node somewhere here. And I will save this as 1D start maybe. Start. Maybe that's a good way to make sure that you get the correct results, the working results. Yeah, defocusing. We have to activate the defocus, enable depth of field function. I will also increase the diffuse bounces, like described in the previous tutorials. On default, you only have basically direct lighting, but we want to have some bounces too. And yeah, we will activate it here in the global settings. You can also do this on object level for each object individually. So this is, we can basically force Renderman on this object to only use those settings. But when we want to make sure that all get the same shading and the same ray tracing, we should put -1 into this, which will pick the Riz node results or settings. So let us do this, that should be okay. And now we have to add the render parameters for the camera. Here we have also the option to use a lens shader, what we don't want to do right now. And I will go to the sampling tab from Houdini. I don't know if this will work, I hope, but I'm not sure, because I don't pre-scaled the object. Okay, now I need to define the focus area, so I will create a null. Oh, we don't need that null. We can go to the camera and we turn the camera a bit in our scene. And here we have a handle, and this is our focal point. And our focal point should be exactly at the position of the sphere. So this should do the trick and re-render again. So the focal point is exactly at the spheres, and now I can try to move the font into the background and let us see how this will look. In that area it should be unsharp. So okay, this doesn't work properly, so this is because I don't use the real scene scale. So in that case, it's better to dial down the f-stop, so maybe do something like that. Those values are really not matching real world scales. So, but in the end, it should look accurate. Maybe we go to this one. Maybe that's a bit too strong. So when we move the font into the foreground, let us check again. It should really match up. So maybe we can try this one. And yes, I believe it looks correct. So we also need to apply a material to this object to have the option to isolate it in compositing. So that means we need to create another object, and this object what we can do is we copy this one, and yeah, maybe it's better to, oh, I already applied the material. Oh my gosh, what happened to me today? Yes, the font already has a material, so sorry. So we can rename this as fonts. And we can add maybe some subsurface scattering right here. Maybe some single scattering, or maybe not, but maybe something like this. And maybe we can add some color, maybe blue, maybe that looks nice. And we go to exponential path trace, which will create much more realistic subsurface scattering on ray level. So this is an approximation, and this is the path tracing variant. So we see that light is moving into the object and fading out on the left side. And maybe we can dial this down a bit right here. So yeah, and what we can do now is we have this in our Cryptomat. So when we stop that, and now we have it also with defocusing in our path. And the only thing that we need to do right now is we do a final render of this image. So I will call it 1D final result again. And we will render out everything to the background. We also want to activate denoising. As I've mentioned in the last tutorial, what we need to do is we need to add those tags to this. So when we go back to the LPE documentary, we see that we have to use, or we have to be strict to the naming conventions in order to have a correct denoise. So all of our beauty passes that we use, or our specular reflection passes and so on, should have to use those tags. So we need to go back to Houdini, and yeah, now we have to add those tags. So for those reflection passes, we basically add specular, like described right here. You can also copy paste this as a tag in front of our passes. So we do this here. It's highly important that we don't do that to those 3 layers. And we also need to make sure that we have activated important sampling, because we want to denoise, like I've said. The next thing that we want to activate is adapt all. So, and here comes the little problem that I've mentioned in the last tutorial. To be able to denoise AUVs or custom LPEs, you need to put those onto the second display. The first one is dedicated only for the variants file, and the second one is the one that we used. So the first one is our variants file, which means we activated the denoise function. And on the second display, we have to basically put all those entries right in here to duplicate this display with all those settings. This is not possible at the moment, so I will hold Alt and will create a duplicate of this one. And here we will activate the parameter window, and then we will go to our main one, to the second display, number 1. We need 6 entries. And now here comes the fun part, or maybe not. We will push those lines right in here as text with drag and drop. So this one. Oh, here I made a mistake, so be careful. So this is the unoccluded. And the other thing that we want to have is those one, this one, this one. So we basically don't need that. So I think we got all. Now on the first one, we go to this page and hit clear. So we have those displays only on the second one. The first one is clear, but we have activated denoise. And here we only have activated that one. Make sure that you have those beauty pass options activated. So don't come to the idea that it can save any space when you're deactivating those. I mean, it can save space, but the denoising process will not start. You will get an error message. So the bad thing is you render those beauty passes. I will not say twice, but you will output them twice. So yeah, but that's no problem because this has no render extra costs, as far as I can say. So then we need to define a render path. We want to output everything to, where is our tutorial, to, I already test that because this is why you can see that. So this is our variance file, so we can name this sphere variance, and this is our, now we can copy paste that, and this is our AOV layer, more or less. We activate the OpenEXR function on both. We render out to zips. This is correct. And now we will close that one to make sure that this thing is cleared now. So important sampling is activated. Those stuff is sphere test, correct naming. So now we do a test. Okay, we go back one step to make sure that everything is working. We go back to it. You have to do this then on both. And here we need to check if the layer is rendered correctly. Maybe we can also add some stuff to the scene itself. So here we have our shadow path. The sphere is not hitting the ground. Maybe we can correct that so that we don't get any problems in compositing. Move this a bit lower, maybe right here. So it hits the ground. Occlusion, unoccluded. Reflection, yes. So we will add some other layers too. So this is the old one, we can delete that. We will add on the second display another layer, maybe two. And the first one we call this diffuse, because we want to denoise it. Diffuse SSS fonts, and here we choose the subsurface scattering function, but we will add a mask for that, apostrophe, and then we will call this fonts or font, and then we will take this one and go to our object, our font object, and we'll, in the lighting attributes, we will put the font inside. So we mask out this layer. So I hit it again. And now we have the subsurface scattering only for the fonts. And as you can see, no speculars and so on. So maybe we should add a specular layer again. So this is just for demonstration. You don't really need that. This is only for adapting or masking and so on. Because you already have all those features like specular, reflections and so on. You already have this in your beauty path. So this is just optional and for demonstration purposes. So yeah, but we will call this also specular, but this time specular reflect fonts, and here we will use maybe this is all direct lighting, so direct specular, maybe that works, and copy paste this one into that. So, and yeah, so we have an additional reflection path for compositing to be able to adjust or to use it as a mask or to add more speculars to it. So yeah, you can do what you want. You can create multiple different layers, and what you can also do is you can specify, like described in the documentation, you can specify how many bounces you want to have. You can say, I only want the 4th to the 8th bounce. In that case, this would require to type it in or to put this section into your code line. And in the end, you need to figure out what is fitting to your specific shot. It's different in every shot that you will work on. You can also use to use those masks and so on for excluding or including lights, and I will demonstrate this basically now. So what I can do is I can also create a mask for a light, and we can maybe create something special for compositing. We can create a new sphere light. We will create a new sphere light. Pixar sphere light. We will make it small. Put it right here. So we will test this first of all, if this is working. And then we'll make it really bright. So we will get some additional light right here. Maybe we should move this closer to see if it has an effect. Okay, it has an effect. This is nice. So we will see it in the reflection here. Of course not here, because this is, and also here. So what we first of all have to do is we click on the light, we go to the, where is it? To the advanced tab, and we call this, we call this second light. Let us call it second light. Second light, and then we go to this one, and we will duplicate the subsurface scattering channel like this, and here we will define, to make it easy, we will define in each layer what type of light we want to use. So without getting any trouble, we will do it fairly easy. We will also give a light group to the dome, so we will call it dome, and so we are sure on the safe side to have everything properly So for that, I will go back to this one. This makes it, oops. We'll copy paste this one. And also here, also here, and also here. And here we go into that angle bracket apostrophe, and here we'll call dome. And then we will copy it to each of those. So you see what you can do with those functions. And right here, also right here. No, in the last one, because this is a copy, we call it SSS second light. And also put it right here. So I hope second light. I hope this is working. Stop, restart. And now I hope everything is working out nicely. This is looking correct. Also this one. But now, as you can see, the second light mask only take into account the second light that we have in the mask. The other one should use the old one, as you can see. So we are now able to add artificial light to this font object. So we can also do this on the reflection. Maybe we should do that. So we go back to the wrist node, and where is it? It's here. Maybe we can add this one here, and we call it reflect second light fonts. And here we will exchange this one. So and now we should also have this. Yeah, it's working. So main specular reflections and those from the light. And this is the second light. This is the SSS path. And this is the right reflection, left reflection, unoccluded, occluded, shadow path. So I think we have all. I will save this. I hope you understand the power of that. So our camera, our settings, maybe we can raise up those like I did always in the past, divided by 4. So I took this maximum channel divided by 4, and now I took this channel, relative channel reference, divided by 4 too. And so we have this and that. So stop. Now we go back to our output, and we want OBXR files. And yeah, let me check again. Important sampling is activated, highly important for denoising. Save it and render to background. And now everything should work, and I will come back when this rendering is finished. So I'm back, and after 4 minutes the image was finished, so I will check it. And here we have our output, and this is the beauty path, and I will split it for checking. And this is the occluded layer, fonts, this one, that one, this one. Okay. So it seems that it has worked. So what we need to do now is we need to denoise those passes. So I will delete that again. We don't need that. So as you know, I am using Armir's tool, Renderman Utility Manager. And this is really nice for denoising AUVs. You also can do this on console. This is much more complicated. You can also do this in PDG these days, but only for single frame and hopefully for cross frame in the future. And when you use this, you can go to the Hyperion denoise tab and go to the directory to our render images, and here we choose the variance frame and the AOV in the second one. So Renderman will only denoise when you have both. And then we maybe can use a JSON file for different presets. We don't do this now. And we choose CPU and hit this button and it will start. And hopefully it will finish soon. I guess something about 40 or 50 seconds maybe. And then we will check our AUVs again. Oh, 18 seconds, this was fast. So here we have a new file called _filtered, which is this one. Here we use the script again to split it up. And this is our denoised diffuse subsurface scattering pass. Our occluded pass is not denoised because we don't specify it in Renderman. So as you can see, when you don't define those attributes, you don't get those layers denoised. The denoising will not happen. So now we come to a denoised layer. This one, it's denoised. This one should not be denoised, as you can see. Also the shadow paths shouldn't be denoised. And specular reflections should be denoised. This one should be denoised. This one and this one. So what we can do now is we can start to integrate another object. So this is basically the second part or the main part. In the end, we want to integrate a better object than only those spheres and maybe this text. This was just for testing. And what I do now is I delete or deactivate those objects. We also don't need that light. We don't need those spheres. So we will put them here. And I will save it to a new file. I will call it 2A start. So this is how we start, and the next thing is we don't need those AOVs at the moment, so we will deactivate those. Maybe all of them, we don't need them right now. Oh, we need them, those 3, but not them. So, and now I will load in another object that I've scanned for this tutorial. And I hope it will work. Of course, those files will also be included. Here we have it. And it's very large. So here we got it. And now we need to scale this a bit. Maybe so. Let us check the size. It's too big. Yeah, that's better. And then we will move it right here. And maybe we make it a bit larger. This looks much better. So even this is not fully correct, but it will look better. So let us turn this a bit. So where was the focal area? It was here, somewhere here, and so let us make a test. So I forgot to deactivate the CryptoMat, so the new CryptoMat is overwritten. This was not a good idea, but I can rename this CryptoMat seashell, and denoise is activated. So don't wander, and we don't need to write this out. So it is totally fine. So yeah, now we need to apply the shader. So when you go into the structure, you basically get a folder looking like this. Here you have all the raw EXR textures, and right in here you have the seashell.rma, which is the shading library, the pre-converted files. And all that you need to do is, we don't need that one. All what you need to do is you copy and paste this folder into your Renderman library, into your custom shader library. In one of the previous tutorials, I have showed how you can create those libraries. And what I did is I copy pasted into a new folder called random and copy pasted right here, so that I am able to access this data. So where was it? So, and that means when I open the Renderman preset browser, I can load my custom library where I have a bunch of different materials in here. And here is my new created folder random, and here is my seashell material. This is pre-converted with the Renderman utility manager, and the only thing that I need to do now is to select the object and import and assign to select the object. And then we should have it here. So the only thing that we need to do now is we maybe need to correct some stuff. The most common thing that we have to do is we need to dial down the displacement value from 1 to 0.01. This is because of the Renderman scene scale. And then we also need to apply those render parameters, and because of the tessellation of the big amount of, so I can show you, because of the density of the scan, I think we don't need any subdivision. So here you see the scan density. It was scanned with about 200 photos in Metashape with a smartphone, and the quality is really, really nice. So here we can correct the positioning a bit so that those objects don't stuck somewhere in the mesh. Oops. Yeah, maybe we need to correct the position a bit more. Let us save this thing as final result. So that's the one we are working on. And here we go. A lot of polygons need to be displaced. Here we have it. And the displacement is too strong. A lot. Yeah. It looks like marshmallow. So also what you see is that the denoiser is more or less working in real time now, since I have a RTX card. So there's no big delay anymore between rendering and denoising. But as you can see, displacement isn't working. It's too strong, so maybe we can go a lot deeper with the value. Of course, this needs to be recalculated. So, I think it's working a lot better, but it's not enough. So maybe we go down to this. We only need a tiny bit amount of displacement, because we have so much detail already in the mesh, because this model is unoptimized. So you can do with the model whatever you want except reselling. And so I think that's working better. I also converted all the textures from the scan with Substance Alchemist, which is really nice in handling the lighting with AI. Also, the latest update really enhances the capabilities of this AI to extract the features of this texture set. So, and this is looking nice. What I do now is I will temporarily deactivate the displacement, so we have much faster iteration on the shading itself, because we need to add some stuff. So we need to add a bit of subsurface scattering, and the first thing that we want to do is this. We also want to go deeper with the diffuse gain. So the next thing that we need to add is maybe we do that, and we will do that like this. Maybe that. A tiny shader on top. Here you see those tiny reflections, these outer reflections. It's really it's going to look realistic. And the free path value is maybe a bit too... Yeah, maybe we can go a bit... I think this looks really good now. So, yeah, we can try the path tracer maybe. It's a lot slower, but it has more detail in the shading itself. And I will also edit the texture maybe, or maybe not. I think this is really looking nice. The only problem that I have with the model itself is it really looks, it has a very blue tint. And this is not what I want. So I will correct the diffuse color a bit. And I hope it will fix this issue. Maybe we make this a bit darker. And we will reduce a bit of the, and I hope, yeah, it's try and error. That was not a good idea. So, how will it look? That doesn't look real. It doesn't look better, so we do it the other way. We do it directly. Oh, did I deactivate the light? No. Here we have it. Oh yeah, this looks much better. So it was the light I have deactivated, and yeah, maybe we can try to influence the subsurface scattering a bit. So what I will do is I will take the base color and will bring the base color into the color input of the subsurface scattering. Maybe this will change the entire look a bit. I will put a color correction in between. So I will change the color input itself, subsurface scattering color. And yes, it looks much better. Maybe you can try that. Yes. That's also a good one. Dion, better dipole. It looks now almost realistic. Maybe we do this, make this a bit darker. And we also need to add some I want to add some more specularity to this. By the way, when you do the shading and when you don't want to use the preset browser with the entire shader, then you only have to load the file. The shader is right in here, and the only thing that you have to do is you have to exchange this path for each texture. So when you don't want to use it, open the shader, change the paths for each specific texture set according to your downloaded folder where you put everything into this. And yeah, in the end, you have to look if everything is working. And this is looking really nice. I mean, nothing to add anymore. So I will add some additional LPE functions. Give it a name right here. We call it shell, and then we go here. So We need those. And maybe we can rename this to shell, and also here shell. And we don't need that one. We can use this one because it's the same function. We want to have it for the shell. We don't need that one. Specular refract fonts, we don't need that one. And maybe later we will check this one too. So let us check. So this is our diffuse. No, our subsurface scattering path. This is our reflection path. It looks somehow weird. Maybe I should add some normals to the model. But I think this already has some normals. Yes, it already has. It has a wrong shading material, maybe exported from Metashape, which is exporting texture material data now. So what I don't need is that's not a nice way to do this. Don't like that. I will do it with attribute delete so we can grab it much faster. So we don't want to delete that. And we'll add a new one. Maybe 70 degree. So save again, fire. Yeah, there is no difference, I guess. Yeah, not really. This is our reflection path, and I think this is a bit too sharp. So let us go back into the shader, make it a bit more rough. Yes. And also here we should make it more rough. So I will put a color corrector in between. And here I can crank this up a bit to make it more rough. Yeah, this looks much better. So what we can also output, maybe for compositing, we can output the other passes. We can use the normal path for relighting, also the position path. So we are able to relight in post in a 2.5D approach. And maybe we also want to add some, we don't need to export the C value, so the def, because we already have it in the P value, but yeah, we can do this. So here we have it. So, okay, don't let us to work too much on this. I will close this entire thing again. And yeah, I will do a final render and will put this image into the starting screen of this entire tutorial. So you will see the final result. I will share the final file. I think you have learned how to do that. You can look in those files, learn from it, and take care of yourself in this current times. And yeah, more tutorials will follow. Bye. Have a nice evening.